In October 2017, the Pan-STARRS telescope in Hawaii caught a glimpse of something that shouldn't have been there. It was moving too fast to be a resident of our solar system, clocking in at 26.3 kilometers per second relative to the Sun before its encounter. It was dubbed Oumuamua, Hawaiian for a messenger from afar arriving first. It was our first confirmed visitor from another star. But as we looked closer, the messenger refused to speak a language we understood. It was too small to be a planet, too quiet to be a ship, and too strange to be a simple rock. First, there was its shape. Most asteroids are roughly spherical. Oumuamua's light curve, the variation in its brightness as it tumbled, suggested an extreme aspect ratio of at least 10:1. In our own solar system, we have never seen a natural object of this scale with such a geometry. But the real mystery wasn't its appearance. It was its movement. As Oumuamua rounded the Sun and began its exit, it did something that defied gravity. It accelerated. In orbital mechanics, gravity is the absolute law. Yet, Oumuamua was being pushed by a non-gravitational force of approximately 5 times 10 to the negative 6 meters per second squared. To an astrophysicist, this usually means one thing: outgassing. Like a comet, the Sun's heat should be vaporizing ice, creating a jet of gas that acts like a rocket engine. Yet, despite our most sensitive infrared observations from the Spitzer Space Telescope, we saw no tail, no dust, no carbon-based gases. The engine was invisible. To maintain a natural explanation, we had to look toward the exotic. Perhaps Oumuamua was a hydrogen iceberg, a chunk of frozen molecular hydrogen formed in the cold heart of a giant molecular cloud. Hydrogen outgassing would be invisible to our telescopes, providing the necessary thrust without a visible coma. However, the physics of the interstellar medium presents a problem. Over millions of years, the ambient starlight of the galaxy would likely evaporate such an iceberg long before it reached our Sun. Then came the nitrogen hypothesis, a fragment of a Pluto-like planet from another system. While nitrogen ice fits the data points, including the lack of a visible tail, it requires a galaxy teeming with these fragments. By some estimates, the mass of parent Plutos required to produce such a population exceeds our current models of planetary formation by orders of magnitude. If the push wasn't coming from evaporating gas, what was left? Harvard astrophysicist Avi Loeb proposed a more radical solution: solar radiation pressure. For sunlight alone to push an object this significantly, that object must have a very high surface area to mass ratio. If Oumuamua was exceptionally thin, less than a millimeter thick, the mere pressure of photons hitting its surface could account for the observed acceleration. Nature, as far as we know, does not produce sheets of material like this, but technology does. We call them light sails. Under this lens, Oumuamua is not a rock, but a piece of derelict technology. Its arrival velocity was surprisingly close to the local standard of rest, the average velocity of stars in our galactic neighborhood. This is precisely what you would expect from a buoy or a probe placed at rest in the galactic frame, waiting for a star system to sweep past it. We listened for radio signals with the Green Bank and SETI telescopes. We heard nothing. Oumuamua has now retreated into the dark, passing the orbit of Neptune in 2024 and heading for the edge of the Kuiper Belt by late 2025. As a scientist, I must tell you, the consensus remains cautious. Without a smoking gun, we cannot claim it was an alien probe, but the anomalies remain. Oumuamua is a Rorschach test for our place in the universe. Do we see a galaxy of dead stones or a galaxy of ancient explorers? The messenger has passed, and it may be the only one we see for a generation. But it has left us with a haunting realization. The next time a visitor knocks, we must be ready to chase it. Because the greatest mystery of the 21st century is currently disappearing into the interstellar night, carrying its secrets into the void. Dedicated to the next interstellar visitor.